Welcome to Summer 8.1. We are moving to 8th grade math. This is more geared towards pre-algebra more than Algebra 1. Algebra 1 is typically considered a ninth grade course. So we're going to start with one-step equations. One-step equations take one step in order to isolate the variable. We're going to get this variable by itself, and we're going to ask the question, what's happening to that variable? Well, what's happening is 4 is being added to it, so the inverse operation, so the inverse of adding would be subtracting 4. That positive 4 and negative 4 will cancel, leaving us with y. And then we have 9.5 minus 4, which gives us 5.5. That's a horrible 5.5. Let's do that again. 5.5. Okay, so we are going to leverage the inverse operation. If we have, here's our operation. Here's the inverse of it. So addition would be subtraction. The inverse of subtraction would be addition. The inverse of multiplication, the most common one is division. But I want you to understand that there's actually a second inverse to multiplication, which is multiplying by the reciprocal. So that is an important one for you to pay attention to. And then the inverse of division is multiplication. So be very aware that multiplication has two inverses, typical, division, and then we also have multiplying by the reciprocal. So we'll see probably examples within this lesson. Let's look at number 2. Okay, this subtraction sign, this negative, this is very important. We need to understand this key concept that negative 1/2 is equal to negative 1 over 2, which is equal to 1 over negative 2. It doesn't matter where the negative sign is, if it's outside, if it's in the numerator or in the denominator. They are all the same. So if it's in the denominator, we can move it to outside. If it's in the denominator, we can move it to the numerator. If it's in the numerator, we can move it to the denominator. A negative sign just tells us direction. That's all. So it doesn't matter if it's here, it's still left 1/2. Doesn't matter if it's in the denominator, it's still left 1/2. So this is really, we can look at this as negative. No, we're not going to put the negative there. That's not what I wanted to show. I want to show that we can write x over negative 9 equals negative 8. So what's happening to the variable is being divided by negative 9. The inverse of dividing by negative 9 is multiplying by negative 9. This allows me to do this to isolate the variable in one step. Numerator cancels with denominator, and we're left with x equals positive 72. A negative times a negative is positive. 8 times 9 is 72. What's happening in this example to my variable? 2/3 is being subtracted. The inverse of subtracting 2/3 is adding 2/3. We're going to add 2/3, and a negative 2/3, positive 2/3 cancel, leaving us with z. Now we need common denominators, and I noticed that there were a fair number of students who did not understand that in lesson 7.1. So we need a common denominator. We have to create equivalent fractions. Common denominator is 24, so we'll multiply that by 3. We get 3/24. We're going to multiply that by 8. We get 16, and that gives us 19/24. Now we combine their numerators, and we keep the denominator, giving us z equals 19/24. That can't be simplified, so we are good. This is our first two-step equation. That's not a two equation, it's two-step. And so if we look at the variable, two things are happening. 9's being added to it. That's not a subtraction. This is connected to the 3. So 9 is being added to it, and -3 is being multiplied. We want to get rid of things being added and subtracted first. So we're actually going to subtract 9 because we have a positive 9. What gets rid of a positive 9 is a -9, leaving us with 6 equals -3a. That negative is still attached to the 3. So keep that negative attached to the 3. And that will leave us with this. And what's happening to my variable? It's being multiplied by -3. The inverse of multiplying by -3 is dividing by -3, leaving us with -2 equals a. And that would be our answer. Now, we could always go in and check. This is a good, interesting step. If we want to check our answer, we take the starting equation and we're going to substitute this value in for a. And we have 9 minus 3 times -2. 15 equals 9 plus 6. We're not moving things. We're just simplifying down this right side. And we get 15 equals 15. If the left side equals the right side, that means our answer is correct. A equals -2 is a solution. That's what the check provides us. Well, this is good. So this is a very, very interesting problem. There are two ways to do this problem. We can distribute and simplify and then move the variable or isolate the variable. And that is definitely one of the techniques. If we distribute this 4 into the parentheses, we get 4b plus 20 minus 9 equals -7. We're going to combine these like terms. We always simplify before moving. Then we can subtract 11. 4b equals -18. Divide by 4, divide by 4 gives us b equals -18 fourths. I must simplify. You can't do this and you can't say or. There's only one answer that is acceptable here. So very important for you to understand that all fractions must be simplified. So we got to reduce that by 2, which gives us -9/2. That answer is acceptable. You don't have to convert it to a mixed number. You don't have to convert it to a decimal. So let's show the other way. Let's clear the ink. So here's a very interesting thing. We have our variable, and our variable is inside Chewbacca. Chewbacca is the parentheses. So we have these parentheses that are protecting my variable. I can't get to my variables just yet. And if I look at Chewbacca, something's multiplying and something is subtracting. So I can get rid of the stuff around Chewbacca. So I can add 9 to both sides, giving me 4 times the quantity b plus 5 equals 2. -7 plus 9 is 2. And now I can divide by 4, leaving me with b plus 5 equals 1/2. And then I can now, once I get rid of that 4, Chewbacca goes away. And I can subtract 5, giving me b equals -4 and 1/2, which is the same as -9/2. This is the way high school students, this is the high school technique. Most high school students would do this, okay? Most middle school students would do this. This is inefficient. Distributing to make it bigger just to make it smaller Doesn't make sense. This is how Mr. Mack will do it in class. This is the most efficient technique. Solve the equation. Ooh, this is a good one. I love this problem. All right, so we have 9j minus 8 equals 8 plus 9j. I always move my variables first. We have variables on both sides. We have constants on both sides. I'm always going to move my variable first. So I'm going to move it across. These cancel. These actually cancel also to make 0. And you're left with negative 8 equals 8. This is a very interesting situation. When variables cancel, and you get a false, in this case it's false, a false number statement, the answer is no solution, meaning there is no number that you can plug in to make this equation true. So my answer is going to be no solution. If it was true, if variables cancel and you get a true number statement, much like 2 equals 2, then the answer is going to be infinitely many solutions. Another answer could be identity. You might see identity. You also may see all real numbers, because every number is a solution. If the variables don't cancel, I mean, if you're still left with a variable, then you can just solve for that variable. You would get a solution like this. But in this example, the variables canceled and you got a false statement. That is false. I shouldn't do it in green. That makes no sense. So we get a false statement. So my answer is no solution. Solve the equation. Again, we have variables on both sides of the equation. 3.8n minus 13 equals 1.4n plus 5. I'm going to tell you to always move the variables first. These cancel. You're left with 2.4n minus 13 equals 5. Now, this is a two-step equation. Once we isolated our variables on the same side of the equation, now we're going to add 13. We get 2.4n equals 18. We're going to divide by 2.4. And that leaves us with n equals 18 over 2.4. We can't leave that as an answer. Can't have a decimal on a fraction. We could move the decimal point one place over in the numerator and the denominator to get 180 over 24, which would reduce to 90 over 12, which would reduce to 45 over 6, which would reduce to 15 over 2, I think. I'm dividing it by 3. Yeah, so 15 over 2. Would that be your good answer? Yeah, 15 over 2, 7.5. I like that. That works. Okay, that would be your answer. Again, I'm not going to change it to a decimal. That's doing more work. Number 8, same thing here. Now, we can't do that two-step. Remember how we did the high school method? Where's my high school method? High school method. We could do this because there was only one variable. variable is on here, we could isolate it. In this situation, we can't move it around because we've got variables on both sides. So we're actually going to have to distribute this time around. It's going to be the most efficient way. 9 times 8d is 72d. 9 times negative 5 is negative 45. Plus 13 equals 12d minus 2. I'm going to simplify. Always simplify both sides before you... Oh, that's not a plus 32. That's a minus 32. Before you isolate. Equals 12d minus 2. All right, I distribute and I combined like terms. Now I'm going to move variables first. Minus 12d gives me 60d minus 32 equals negative 2. We'll add 32. We get rid of addition and subtraction first. 60d equals 30. Divide by 60. Leaving us with d equals 1/2. That's a good one. I like that problem a lot. Let's move on to the next one. Fractions. Okay. I'll show you the long technique, and then I'll show you what a high school student would do. So again, we have variables on both sides, so we will have to distribute this into the parentheses. So that gives us 1/4 t plus 4 equals 3/4 t plus 6. 3/4 times 8. 4 in the denominator cancels with 8 in the numerator, leaving us with 2. And 3 times 2 is 6. I'm going to move my variables first. I'm going to subtract the 1/4 t, leaving me with 4 equals 1/2. You'd get 2/4, which simplifies to 1/2 plus 6. We'll subtract 6. Negative 2 equals 1/2 t. I'm not going to divide by 1/2 because that would give me a funky fraction. So this is the one example where I'm going to multiply. 1/2 is multiplying t. The inverse of multiplying is multiplying by the reciprocal. The reciprocal of 1/2 is 2. And my final answer is negative 4 equals t. So that's how I would do, that's how a middle school student would do it. I'll show you how a high school student would do this problem. So what they would do is they would get rid of all of the fractions. They'd multiply everything times 4. 4 times 1/4 t gives us t. 4 times 4 is 16. 4 times 3/4 equals 3 times t plus 8. And now I don't have any fractions in here. And now I can just distribute. T plus 16 equals 3t plus 24. I'm going to subtract my t. 16 equals 2t plus 24. Subtract the 24. This gives us negative, what's that, 8 equals 2t. And I'm going to divide by 2, and we get negative 4 equals t. Same answer, just a little bit more efficient. Both are correct answers. Number 10, the sum of the angle measures of a triangle is 180 degrees. Find the value of x, then find the angle measures of the triangles. Okay, so first we know that the sum of the angles of all triangles is 180. So this angle plus this angle plus this angle equals 180 degrees. We're going to simplify. We're going to add like terms, which gives us 4x plus 8 equals 180. We'll minus 8 from both sides, leaving us with 4x equals 172. Divide by 4. X equals 43. So x is going to be 43. So one of the angles is going to be 43 degrees. And then if we plug in x for this, one of the angles in order least to greatest. So my next angle is going to be 43 plus 8 or 51 degrees. And then my third angle is going to be double, which is 86 degrees. Those three should absolutely add up to 180 degrees. So 43, 51, and 86. Good. And x equals 43 degrees. Yep. It's a good question. I like that. Mr. Mac likes all math questions. Always want to be challenging myself, sharpening my brain. The formula for the perimeter of a rectangle is perimeter equals twice the length plus twice the width. That makes sense because perimeter is the distance around. You have length, width, length, width. So you have two lengths, two widths. So it's 2L. You will also see the equation 2 times the quantity L plus W also equals the perimeter. If we distribute out the 2, you get 2L plus 2W. Solve the formula for W. Okay, so we want to get W by itself. So in the equation, P equals 2L plus 2W, we're isolating for W. We're going to get that variable by itself. Two things are happening. It's being multiplied by 2, and it's being added. 2L is being added to it, so I'm going to get rid of things being added and subtracted first. So I will subtract a 2L, giving me P minus 2L equals 2W. These cancel. I'm left with 2W. And now I'm going to divide by 2. And that gives me P minus 2L over 2, which is a common equation for it. Now, I don't like or statements, and I don't like giving me two answers. Don't give me two answers. Pick one. Make a decision. But I will tell you that you could see this equation, P divided by 2 minus L equals W. This is the other one you might see. We can't cancel these 2's just by themselves. This 2 is under the P and under the negative 2L. So if we separate them and put them under, you're left with P over 2 minus L equals W. Use the new formula to find the width in meters of a rectangle with a perimeter of 2 meters and a length of 4 centimeters. So notice 1 centimeters, 1 is meters. That's there to trick you. Oh, you trickster. So let's turn 2 meters into centimeters. This is in a different... So 2 meters equals how many centimeters? Well, we have this thing. King Hector died, unfortunately, drinking chocolate milk. And this is the metric system. Kilos, hecto, hecta, deca, units, deci, centi, milli. So we're currently in our units. Meters, liters, and grams are my units. So I am in 2 meters. So I'm here, and I need to get to centi. So I'm going to move my decimal point from meters to centi. So I'm going to move the decimal point 2 places to the left. So my decimal point at the moment, when we're talking about 2 meters, is right here. And we would move it 1, 2 places to the left, and we would add some zeros. And now it would be in centis. So 2 meters equals 200 centimeters. Okay? And now we're going to plug that in for my perimeter when my length is 40 centimeters. So we're going to use this. My perimeter is going to be 200 over 2 minus my length is 40 equals my width. So this gives me 100 minus 40 equals W. And so my width is going to be 60 centimeters. That is the length of my width. Find the width in meters. So sorry. Now, reading the directions, it wants it in meters. So that was kind of dumb of me to convert it to centimeters when I should have been converting it. But that's okay. This was nice. It worked. We just need to now convert that to meters. So centimeters, we're going to use our King Hector again. King Hector died. My unit is meters. Drinking chocolate milk. And right now I'm in centimeters and I need to get to meters. So I'm going to move the decimal point 2 places to the left. So my decimal point right now is right here. I'm going to move it 2 places, and that would make it 0.6 meters. So my answer is actually 0.6 meters. Let's erase that little, because this is wrong. Okay, so converting 60 centimeters is equal to 0.6 meters. You should definitely know how to utilize King Hector died, unfortunately, meaning units, drinking chocolate milk. Super easy, very, very useful mnemonic memory aid. All right, solve for y. Solve this equation for y. We have 0.5 equals 0.4y minus 0.25x. We got to solve for this variable, for y. So we got to get rid of the thing being multiplied and the thing being subtracted. Okay, we're going to get rid of things being added and subtracted. So the inverse of subtracting 0.25x is adding 0.25x. We can't combine these. These are x-rays. These are dollars. These are unlike terms. So we're going to write 0.25x plus 0.5 equals 0.4y. Now we're going to divide by 0.4, and when we do that to one side, we have to do it to everything on the other side. We might want to convert this. We can't have decimals and fractions, so in order to get rid of this decimal, I have to move it 2 places. So that would give me 25x, and I would have to move it 2 places in the denominator, which would give me 40. Here we only need 1 place. That gives us 5 over 4, and this gives us y. Now I can't have this. This needs to be simplified. 5 goes into both of those. 5x over 8 plus 5/4 equals y. That would be my answer. If they want it as a decimal, that's fine, but I like it like this. I don't want to do more work. I'm comfortable with fractions. Fractions can be easy if you understand them. Your basketball team wins a game by 13 points. Okay, that's good. The opposing team scores 72 points. Explain how to find your team's score. Your basketball wins a game by 13 points. So it's gonna be 13 more than the opposing team. So my team score is going to equal my opponent's plus that's just highly too complicated. So my score is going to equal the losing score plus 13. Explain how to find the team score. You're going to take the team score and add 13. So that gives us 85 points for my team. Well, that's probably how I'd explain it. It's not the best, but it's the opponent's team plus how much we won by. I mean, that's really what it's about. Ooh, that's really, really small. I don't know if I can even read that. Let's do this. Let's view, zoom. Let's zoom out. You are biking at a speed of 18 miles per hour. You are 3 miles behind your friend who is biking at a speed of 12 miles per hour. Write and solve an equation to find the amount of time x it takes for you to catch up to your friend. Okay, you're biking at a speed of 18 miles per hour. I'm going distance equals rate times time. So my distance is going to equal 18 miles per hour times the number of hours. That's me. My friend, who's not really a friend if you're 3 miles ahead of me, why can't we just ride our bikes together? Distance equals rate times time. D equals, he is riding at 12 miles per hour. And it says write and solve an equation to find the amount of time X takes for you to catch up to your friend. Okay. So when does, well, if we subtract these, it should equal 3 miles. So 3 miles, which is the distance between us, should be, well, how much time would it take me riding at that? Is that it? Oh, how much time? Yeah, I think I kind of like this. Yeah, this makes sense. This is probably a little bit more technical than what I had wanted. Divided by 6, divided by 6. It's going to take 1/2 hour. I like that. Yeah, that's okay. I like that. I'm subtracting his rate of speed minus my rate of speed, which is a difference of 6 miles per hour. And if the difference is 6 miles per hour as we ride, I'm going to gain every 6 miles per hour. And if I only need to gain 3 miles, that would take me a half hour. It kind of makes sense saying it in that manner. Two scientists are measuring the temperature of lava. One scientist records a temperature of 1,725 degrees Fahrenheit. The other scientist records a temperature of 950 degrees Celsius. Which is the greatest temperature? So we're going to need to know that formula that we saw. I think it was in 7. Well, we saw it in one of the situations. So let's find the formula to convert Celsius to Fahrenheit. And what is the formula? Ooh, that's an ugly formula. Let's do Fahrenheit to Celsius. Fahrenheit. Yeah, we have two equations. This one's a little bit easier. Here's the other one. You're given Celsius, it converts to Fahrenheit, or, well, Celsius to Fahrenheit, that's much better. Fahrenheit to Celsius. So these are your two equations that you might want to know. Let's take those and paste them in there. So, ooh, that's good. So they give us two. This is a little tricky. Even though they give us the two equations, they give us two different ones. Okay. Oh, no, they give us which. Okay, I got it. They didn't give us. They said which one. Is it the Fahrenheit or the Celsius? So I'm going to take this Celsius and I'm going to convert it to Fahrenheit. So Fahrenheit equals my Celsius degree, which is 950 times 9/5 plus 32. The reason why I did that was because 5 goes into 950, 190. We're going to multiply it by 9, which gives us 0, 1, 170, 11710, 1710 plus 32 gives me a final temperature of, sorry, 1,742 degrees Fahrenheit. I'm going to check my math first. I did the calculations and then I'm going to check. So we got 950 divided by 5 gives us 190. We're going to multiply that by 9, which gives us 1710. So I'm good. And when we compare it, 1742 to 1725, 1742 is more. So my answer is going to be 950 degrees Celsius is the greater temperature. Good. Could have gone the other way if you wanted. Last question. Your profit from mowing lawns this week is $24. You were paid $8 per hour, and you paid $40 for gas for the lawnmower. How many hours did you work this week? Okay. Ooh, this is good. So, you're paid $8 per hour and you paid 40. So I know that we're assuming that I used all the gas in the mower. You don't, it doesn't say that. We're making the assumption that we used all the gas. Maybe we filled it up twice. Maybe we didn't use it all. Maybe we didn't need $40, but you paid for $40. So that's an expense plus this. And then so 8 times T should equal 40 plus 24. So we get 8T equals 64 divided by 8 divided by 8. T equals 8 hours. I would need to work 8 hours in order to make a $24 profit. That's my profit. That's how much I spent of my total money that I was paid. We would divide it by 8 in order to equate to $8 per hour. All right. There you go. Those are the answers. You all have a great summer.